Okay, lesson 7.4, we're going to learn about some special parallelograms. Okay, so one of those is a rhombus, and a rhombus is a parallelogram with 4 congruent sides. Okay, so not only are both pairs of opposite sides parallel, but all 4 sides are congruent as well. Okay, then a rectangle is a parallelogram with 4 right angles. Okay, you can see that there. And then a square is a parallelogram with 4 congruent sides and 4 right angles. Okay, which would mean that they are also congruent. Okay, corollary 7.2, a quadrilateral is a rhombus if and only if it has 4 congruent sides. Okay, corollary 7.3, rectangle, a quadrilateral is a rectangle if and only if it has 4 right angles. And a quadrilateral is a square if and only if it is a rhombus. Okay, I'm going to add something there in just a second. And a rectangle. Okay, well, what does it mean to be a rhombus? It means 4 congruent sides. Rectangle means 4 right angles. Okay, once you're done there, you can turn the page. Okay, so this Venn diagram below illustrates some important relationships among parallelograms, rhombuses, rectangles, and squares. For example, you can see that the square is a rhombus because it is a parallelogram with 4 congruent sides. Because it has 4 right angles, the square is also a rectangle. So in example 1, it says, for any rhombus QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. So angle Q is congruent to angle S. So if I draw this rhombus, okay, we know that they're all the same. We know that the opposite angles are congruent, okay, and then go in this order, Q, R, S, T, okay, that would be true because in the order that they gave it in, they're going to be opposite of each other. So that would be always true because opposite angles are congruent. Okay, but as we can see in this picture here, angle Q is congruent to angle R. Okay, well, that's not always true, but if our rhombus looked like this, then it would be. So that would be sometimes if rhombus is a square, 2. Okay. Example 2, classify the special quadrilateral and explain your reasoning. So we see 70 degrees here, which means that there would be 70 here. Okay, and then I would do 360 divided by 2 to figure out what these other 2 are. Okay, but I know that they're not 70, okay, because I can tell just by looking at it. So I can say that this is a rhombus because all 4 sides are congruent, but not angles. Okay, you can turn the page. So then we have more about a rhombus. So theorem 711, rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if we have not talked about what perpendicular means to this point, it means that they make a 90-degree angle. Okay, they meet at a 90-degree angle. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay, so only if it's a rhombus do the opposite angles get bisected by the diagonals. Okay, so in example 3, it says find the measures of the numbered angles in rhombus ABCD. Okay, well, off the bat, I can say that the measure of angle 1 is 90 degrees, okay, because it's in there in the middle. So that's 90. Okay, then it tells me that the measure of angle ACD is 61. So then I know that 2 and 3 have to also be 61, because those are all 61. So the measure of angle 2, measure of angle 3 are all 61 degrees. Okay, and then to find the measure of angle 4, I know that angles 1, 3, and 4 all make this triangle. So those need to add up to be 180 degrees. Okay, so to find the measure of angle 4, I'm going to do measure of angle 4 plus 61 plus 90 equals 180. Okay, and you would solve that to figure out that the measure of angle 4 is 29 degrees. Okay. All right, theorem 713, the rectangle diagonal theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so the full length is congruent. Okay, so turn the page there. So it says you are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? So your answer would be no. The opposite sides are congruent, but we don't know anything about the angles. Okay, it says you measure the diagonals of the opening, and the diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? You can say that it is not a rectangle because the diagonals are not congruent. Okay, example 5. In the rectangle QRST, QS is 5x minus 31 and RT is 2x plus 11. Find the lengths of the diagonals of QRST. So we know that the diagonals are equal to each other or congruent. So I'm going to set them equal to solve for x. So I'm going to add 31 to get 2x plus, that would be 42. Subtract 2x and you get 3x equals 42. Divide by 3 and you get x equals 14. Okay, now it wanted to know what the lengths were, so I'm going to plug that back in. So 2 times 14 plus 11. So that would be 28 plus 11 until you get 39. Okay, so each one, regardless if it's QS or RT, they equal 39. Okay, last example here. So decide whether quadrilateral ABCD with vertices of A at -2, 6, B is at 6, 8, C is at 4, 0, and D is at -4, -2. Okay, and it wants us to decide if that is a rectangle, rhombus, or a square and give all names that apply. Okay, I know looking at that shape, it's not going to be a square, but I have to prove that that's not true, or that that's true, okay? So the first thing, the diagonals would be congruent if rectangle. Okay, so we can do the distance formula for AC and BD. Okay, so you get a big square root. You get -2 minus 4 squared plus 6 minus 0 squared. Okay, and if you do that, you get that it's 72, or the square root of 72. For BD, you would get 6 plus 4 quantity squared plus 8 plus 2 quantity squared. And if you do that out, you get the square root of 200. So you know that those are not congruent, so those are not a rectangle. And because it's not a rectangle, it also can't be a square. Okay, so now what's the easiest way to figure out that it's a rhombus? We want to find the slope of the diagonals to show that they are perpendicular. Okay, so the slope of AC is 6 minus 0 over negative 2 minus 4. Okay, and you get negative 1 there. Now the slope of BD, you get 8 plus 2 over 6 plus 4, which is 1. Okay, and remember, or if we haven't talked about it yet, perpendicular slopes are negative reciprocals of each other. So you're going to flip what's on top and bottom and then change the sign. So some other examples of negative reciprocals would be like negative 2 and positive 1/2, or 2/3 and negative 3/2. Okay, whenever it's the case of 1, right, you would have negative 1 over 1. And if you flip it and change the sign, not equal, sorry, the negative reciprocal would just be positive 1, again, over 1, which is just 1. So those are true. So ABCD is a rhombus. Okay, there's that.